Hi, it's Renata here. If it's your first time here, welcome to my channel, The Quanti Girl, where we are going to talk about some topics in applied mathematics, in pure mathematics, in quantitative finance, and in Python program, because I'm a PhD in mathematics and a financial quantitative analyst, and I'm here to share with you some of my experience. So today we are going to talk about scenario analysis, and after we talk about the theory, we are going to implement it on Python. So we can start with the question: why scenario analysis is a powerful tool for an investor or for a risk manager? Well, scenario analysis gives a probabilistic idea about what the future could look like. And it is a very powerful tool for us because we can't predict exactly how the future will look like. So in scenario analysis, basically, we have a phenomenon and we try to give a view in terms of probability of possible future scenarios that happens because of this phenomenon. So we start with some assumptions, and then from this we simulate future scenarios based on these assumptions. Like all things that uses data as input, the more data we have, in our case, the more scenarios we have, the more accurate will be the results. A classic example of a scenario analysis related to portfolio risk management that we can mention is to answer the following question: what's the probability that a portfolio will lose a percentage, for example 2%, within 30 days? In our study here, in our analysis, we are going to make first a strong approximation, but that can be a good start point. We are going to simulate future returns of a portfolio of stocks here as a random resampling from the past returns. So first of all, we are going to define a portfolio of stocks. So our portfolio will be composed by Apple with the weight of 40%, Google with the weight of 30%, Amazon with the weight of 20%, and Tesla with the weight of 10%. So now that we have our portfolio composition, for each stock of the portfolio, we are going to calculate the daily returns of the closing price, and after we have the returns, we are going to simulate any days of our portfolio in the future, selecting randomly and uniformly any values with the replacement from our daily return series. We can see a portfolio as a combination of returns and weights. So given each stock of our portfolio and its weight in the portfolio, we can express it as the weighted sum of the stock returns. A consideration that you need to make here is that simply performing simulations considering future returns as random samples of past returns is not enough if you want to make a what-if analysis. By what-if analysis, I mean, we could ask, for example, what happens, what is the impact in our portfolio of stocks if the average daily returns of the stocks in our portfolio goes down its historical value. So to do a simulation here, We are going to do it soon in Python. In our portfolio, we are going to simulate what happens if Apple average return drops by minus 0.005, Google drops by minus 0.003, Amazon drops by minus 0.002, and Tesla drops by minus 0.001. So what you need to do is to subtract these quantities from each stock and then simulate again our portfolio, our future portfolio use the resampling with these new values. So after we simulate you have the simulated scenarios, we are going to analyze three things. First, in order to calculate the chances that our portfolio will underperform or overperform the future cumulative return, we are going to build the 95% confidence interval of the cumulative returns. Second, we are going to calculate the Sharpe ratios of the returns of the different scenarios that we simulated, and then we are going to calculate the average Sharpe ratio. So that's the theory that we needed to talk. Just to conclude, we can say that the analysis we are going to make here can be used, for example, in other contexts others than simulating scenarios for a portfolio of stocks. We could use it, for example, for analyzing the impact of crisis of types of interests, and also for black swans, for example. This type of analysis, scenario analysis, makes possible to assess potential future risks of our portfolio or wherever the object is, and to know its potential of growing up. So now that you talked about the theory, let's go to Python, let's go code and implement the scenario analysis of our portfolio of stocks. So just keep watching the video and code with me. So now we are ready to run our simulation. So the first thing that you need to do is to import the libraries that we are going to use. So we are going to download data from Yahoo Finance. We are going to use pandas to manipulate data frames. We are going to use NumPy especially when we are going to do some statistics of our simulations. And we are going to use matplotlib to plot the results in the final of our simulation. So let's import the libraries. Now we need to specify the stocks that is in our portfolio. As we talked before, we are going to consider Apple, Google, Amazon, and Tesla. So we just write the tickers here, and you download the data for these stocks from Yahoo Finance using the function download from the package Yfinance. So we need to specify the stocks. We need to specify a time interval. We are going to consider here daily data. Of course, we need to specify a start date and an end date. What we need here actually is the closing prices of the stocks. So we are just calling the closing prices here. So let's run the cell. Yeah, so here we have the closing prices for each of the stock in our portfolio in the period that we specified. So now we need to calculate the returns of the daily returns of the closing prices of our stocks. So let's run. Yeah, so now we have the daily returns for each stock in our portfolio in the period that we specified. So now this cell is not actually really necessary, but I'm going to run it here just to show how we can simulate future returns, resampling past returns with the replacement. So for this we just need to use the sample function. So what we need here is 50 days of future returns, simulation of 50 days of future returns of the stocks in our portfolio. Now we are at the point of specifying the final composition of our portfolio. By final composition, I mean the stocks that we are considering in our portfolio and its weights in the portfolio. So as we already specified the tickers, now we need to specify the weights of each stock. So as you talked before, we are going to consider a portfolio with 40% of Apple, 30% of Google, 20% of Amazon, and 10% of Tesla. So now that you have the tickers and the weights, we are going to write our portfolio as a list of pairs where each pair is the stock and its weight in the portfolio. So this is what I wrote here. And finally, we are going to build a function to simulate a quantity of days of our portfolio. So our function has 3 parameters: the number of days that we want to simulate and the series from which we are going to simulate, and the portfolio composition. So we need to initialize a variable where we are going to keep the result. So we are going to initialize it as 0, and for each component in the portfolio, I mean for each stock and its weight, we are going to simulate its returns. And finally, we are going to update the result with the simulations and the weights of each stock in our portfolio. So to check that the function is working, we are going to call the function here, simulating 5 days of our returns. So let's run it. Yeah, it's working. So here we have a simulation of 5 days of our portfolio, and now we are at the point of consider a modification in the return series. So as we talked before, we are going to consider that we have a drop in the average daily returns for each of the stock in our portfolio. So we are going to consider that Apple had a drop of 0.005, Google had a drop of 0.003, Amazon had a drop of 0.002, and Tesla had a drop of 0.001. So we need to subtract these quantities from the original returns series. So we are going to copy the original series and subtract these quantities from this original series. So let's simulate again now, considering the modified data, the returns subtracted by the drops we specified here. So these are the results for the new simulation considering the modified data. And finally, we are going to build a function to simulate a certain quantity of days in a certain quantity of different scenarios. So let's build a function to do that. So our function will have 4 parameters: the number of days we are going to simulate, the number of different scenarios we are going to simulate, the series from which we are going to do the simulations, and the composition of our portfolio. So first of all, we need to initialize the data frame that will keep the results that we need. So we are going to create an empty data frame, and for each scenario, here for each S is the number of different scenarios, we are going to run the simulation. So each in the final of the results, each column of the data frame will be a different scenario, and each row will be a different day in each scenario. So we need to write an if-else condition here. This means that if when we run for each iteration, for each scenario, if the data frame with the simulations doesn't exist, we are going to create it with the last simulation, and if it already exists, we are just going to join the new data with the data frame that already exists. So that's what this if-else condition is saying. And finally, we are going to return the object that we want. In our case here is the data frame with the simulations of any days for each different scenario, for each of the S different scenarios we are considering. So okay, let's run the function. And now finally we are going to simulate 100 different scenarios, and for each scenario we are going to simulate 10 days. So the simulations is done from the modified returns. Remember, the modified returns are the original returns series of the daily close prices of the stocks minus a drop. The series are the modified returns, and the portfolio composition is our final portfolio composition. So let's run it. Yeah, okay. So here we have each column is a different scenario, and each row is a day in each of the 100 different scenarios we simulated here. So now that you have the scenario simulated, we are going to do some statistics about our simulation. So first of all, we are going to build a 95% confidence interval for the cumulative returns of our simulation. So here I just took the average returns, and here we are writing the upper and lower percentages. So let's plot it. Yeah. Okay, the color here is not helping, so let's run without color. Okay, the color actually, we need the color to fill the space, not here. I think it's okay now. Yeah, so we have here the average return and the 95 confidence interval for the cumulative returns. Okay, so as we talked before in the theory part of this video, we are going to ask the question, what is the probability that our portfolio will outperform a given target? So here we are going to consider a target of 1%. So this is the target of 1%. This is the probability of the portfolio outperforming this target, and here are the errors associated with these probabilities. So let's plot it. Yeah, so here, for example, in day 8 we have the probability of outperforming the target of 1% is varying in these quantities, and finally we are going to calculate the Sharpe ratios of the cumulative returns and of each scenario, and after we are going to take the average value of these Sharpe ratios. So we have an average Sharpe ratio of minus 0.22. It's not a good Sharpe ratio. Maybe we can build a better portfolio, maybe change the stocks that we are considering, or making an optimization to find the optimal weights for each portfolio. So we can talk in the future in some video how to optimize weights in a portfolio of stocks. That's all for today. Hope you liked the video. Don't forget to hit the like button because it helped me a lot. And also, don't forget to subscribe to my channel so you can know when I upload the next videos. So, see you next time in the next video. Bye!